And what you see here, every plus here is a measurement made by some ship that was going on a great voyage, and they made measurements of the deviation of magnetic north from true north, and each one of these is pluses shows what's going on. This is before 1590, and you see that the coverage is rather sparse. If you look after 1590, you see that there was lots of maritime trade opening up in here, and so people were making lots more measurements of the magnetic field, mostly of what we call the declination, rather than the whole of the magnetic field vector, because the magnetic field is a vector property of the and so it not only has a direction, it also has a strength, and the declination just measures the horizontal direction of the magnetic field. So people made a lot of measurements. By 1700 already, this is a map. It's actually an example of one of the very early contour maps that was made by Edmund Halley of Halley's Comet fame. And he was interested in the Earth's magnetic field, and he made a contour map of the declination in the Atlantic Ocean. And what you see in here is this big fat line, which is less spidery than the others, is what they called at that time the line of no variation, which is where the declination is essentially zero. If you look at a compass there, you would be looking towards the North Pole. This line actually has moved westward with time, and it's now sitting somewhere over the Americas in the present day. And Halley actually knew already in 1700 that the magnetic field was not a static quantity, and he already knew also that the magnetic field came from inside the Earth. He actually knew pretty much what a lot of people know about the magnetic field today, even though he was looking at it in 1700, though he didn't know as much about the global properties. So, to skip to the 20th century, when we measure the field today, we don't just use a compass, we use a magnetometer, which measures the whole vector of the magnetic field. It measures both the direction and the strength of the magnetic field, and we're able to map it pretty much all over the Earth. That's been done using a series of satellites. The first was the POGO, which stands for Polar Orbiting Geomagnetic Observatory, in the late 1960s and early 1970s. This only measured the strength of the magnetic field, and people discovered that that wasn't enough. In 1979 and 80, there was MagSat, which measured the vector components of the field. And then there was a hiatus while people digested what they learned from MagSat and tried desperately to get more funding to go out and measure the magnetic field from a satellite. And since 1999, there has been a concerted effort, mostly by Europeans,